In this video, I'm going to talk about character setup, including animation graph setup and character blueprint setup, and also about some debug functionality. And then we are going to wrap up this video by talking about some demos. So let's open the navigation demo map. And here I'm going to demonstrate some of the debug functionality that we have and we plan to build in the future. So if you, let me ensure that the paths are built for the AI, because this character is controlled by the AI, where the character is just tasked to follow the various waypoints, which is basically the character tries to find its way to this glowing green orb by avoiding obstacle by using the Unreal pathing system. So if I play, you'll see that the character goes towards the green orb while it avoids the obstacles in the world. So what we can do is, if you open the visual logger and hit record, then we can record what the character is doing along with all the debug that it is performing. So if I stop the simulation and click on the recorded track for the AI controller, and then as I scrub through, then we can see that we are able to recreate both the debug draws and the debug prints down here. And each of the constraint fragments is doing their debug prints here. For example, the pose constraint fragment is doing its print here, followed by the trajectory constraint fragment, and then that's followed by the future or the warping trajectory fragment as well here as well. And then in the world, we also draw the skeletal mesh for easy visualization of what the character is doing. This is essential to determine motion quality issues and understand why is that happening. And that can be done by understanding various costs that the character is producing. And we built a system that allows you to test this costs against other animations that you would like to be picked. Currently, that is not included in this build, but we will provide that in a future update that will allow you to do that. So next I want to talk about how to set up the character to use the motion flow system. And I'm going to talk about that at a high level, so without going into too much detail for this video. So if you open the character blueprint, then you will see that on the left here we have a motion flow component that ultimately drives the motion flow system along with the motion flow nodes that are in the character animation blueprint. So if you open the character animation blueprint, you will see that in the animation graph we have a simple state machine that transitions between various docking actions that the character can perform and a locomotion state. So if you open any of the docking state, for example, here, then you will see that we have a motion flow node here that takes an animation request, which I'll talk, which is basically a combination of what motion data asset to use, that is what style of animations to use, along with the feature vectors that are encapsulated within the data assets, and what constraint to use for that search. So that is what comprises an animation request system, which is an encapsulated request for an animation search. And similarly, if we go to Vault here, then you will see that takes the Vault animation request class in its motion flow node. So when you run the system transitions between these various states as determined by the state transitions, which is a very simple rule here where we check what is the current ability task being run, and ultimately we use Unreal's ability system to drive the gameplay side of things which control the state machine transitions. So speaking of the ability system, we have a data asset that tells what various abilities the character can perform. So for example, the character can perform combat jog, can perform injured run, can perform vault, switch, usage, cover using the left shoulder, cover using the right shoulder. So these are the current data set, these are the current skills the character has using the current data set. And corresponding to each of those abilities, we have a gameplay ability class, for example, the combat jog class, which you can specify what to do when the activity is activated and what to do when the ability has ended. So for example, for combat jog, we make some gameplay state changes that we set the movement mode to walking and enable the collisions. And for example, when you hit the switch button, when that is enabled, you kind of set the mode to flying because you want to, and this is done similarly for vault as well. And ultimately, this is the same logic there. Basically, you want to disable the collision because if you're, for example, vaulting over an obstacle, you don't want your capsule to collide with it. And then you provide optional data to the animation request by setting the animation request data. Which basically provides the location of the task that you're trying to do. For the switch case, it provides you the transforms of where the switch is placed into the world. And then on when that ability has ended, then you here we are launching another switch exit, like exit in a particular direction. So we provide that as a next ability to launch. And if you look at the switch exit ability, so when it ends, then it launches the combat jog. So then that's how you kind of transition automatically between switch to switch exit. And then when switch exit is finished, then it transitions to the locomotion ability. And this is all driven through the annotations that we have done in the animation, where we annotate when the ability finishes by adding an anim notify there that drives these transitions. So going back to our character blueprint setup here. So there are other components over here for trajectory that are collecting trajectory information for past and future, which is ultimately used by the trajectory fragments if they are present for performing a particular search. So the collection of the data is decoupled from the actual search, which is stored inside the constraint and then the constraint fragment. So and then here we have done some very simple setup, like a proper game would probably have a much more complicated setup, but this is to show just the usage of a motion flow system where we have just created the switch action, and when the user presses the key, in our case we have mapped that to the F key on the keyboard, then we'll launch the ability for the switch, and then ultimately the switch ability itself handles the determination of where the switch is and what to do next. That basically tells you, I'm going to do switch exit next. This is done differently for the AI, where the task itself tells the character that perform the switch action on me. So that's something you can look at by looking at the blueprints for the tasks as well. So the other thing that I wanted to talk about in this video is a couple of demos. So we have various coverage tests, for example, and this is driven by AI. And I'm going to delete the visual log character here. And this is where the ability is actually being executed by the task itself when you hit this trigger volume. And this is also can be done completely differently for your game or simulation, but in this case, the way we have set up is when the character hits this trigger volume, then this task itself executes the ability instead of how I just showed previously, where the ability was being executed by pressing a key by providing a user input. So here this vault obstacle itself provides the execution of that ability on the character and provides its own transform by providing that into the anim request data. So if I play, then you can see that the character goes to the desired location, and then once it is trying to go there, it hits that trigger volume that tells it vault over me, and then the character kind of goes, performs the rest of the motion. So there's still work to be done here, as you can see that the character exits in the wrong direction, and because it is not picking the correct direction of exit. So you can perform a secondary search on the top that we are currently building a robust system for that allows you to do that. And I'll touch a bit more on that in the next demo. So and to look at that, to look at the next demo, I'm going to open this rooftop demo, and there are some regression cases here where the character is performing incorrect motion, which we'll fix in a future update. But here, this is a map where the character performs a variety of tasks in succession. For example, vault over this obstacle, and then it goes to perform the cover entry over here. And here you saw that the character went. I'll run that again, and you'll see that the character exits in the correct direction, and that's because we are performing that search. That makes it pick an animation that goes in the direction of the next target. And similarly, when you exit from cover, it picks an animation that goes towards this vault obstacle. So ultimately, there is still work to be done to improve various motion quality issues that are present in some cases, and then we have additional work to be performed on optimizing the system and making it making the API more robust and scalable for usage in large productions. Thank you.